What's up, Mansonites and Mansonettes? It's Miss Sorensen here with our last video in this long unit, video 31, standard deviation and binomial distribution. Let's get started. Find the standard deviation for the number of Smoky days in Manson during those 3 days. You know, this is an interesting question. It basically says from year to year, how much does it vary in terms of how many Smoky days you get each year for those 3 days at the beginning of July. So it's asking for standard deviation from kind of year to year, and we can solve this problem by doing it on Excel again, right? I could go to Excel and I can actually get that answer. So let's do that. Just give me a second to escape out of here, and let's go back to our Excel document. And instead of doing average, here I'm looking for standard deviation. So I'm going to do STD, and I'm going to get the sample standard deviation. And then I'm going to highlight everything. Close my parentheses. Why not? Press enter. And I've got a standard deviation of 0.849. You know, that's quite a bit if you think about it, but it's basically saying it varies about 0.849 days per year in terms of what the standard deviation is. So that would be 0.849 days would be our actual answer. So our answer is 0.849 days. And again, you're saying, Ms. Sorensen, are we going to have to do this Excel thing to get what our standard deviation is? And the answer is no. We of course have a formula for it. So here's our formula. Find the standard deviation for the number of Smoky days in Manson during those 3 days, those 3 days being the first 3 days in July. Well, here's our formula. Certainly get it down, please. N stands for the number of trials, which in this case is the number of days, and we're talking about 3 days. P is the probability of the thing you're referencing, so that would be Smoky days, or the probability of Smoky days. And Q is the probability of the complement, meaning the opposite of the thing we're referencing. So this would be the probability of not Smoky days. So our standard deviation is going to be the square root. What's our number of trials? In this case, it's 3 days. Times the thing that we're referencing, which is going to be Smoky days, which was 0.6. Do you remember that? Times the complement of the thing we're referencing, which was not Smoky days, which was 0.4. And these two things should add up to 1. All right, and I'm going to do that math in my calculator, and I get 0.849. That's good news, right? Isn't that what we got before? And you're welcome to check that to verify that's what you get, but I promise you that it is. All right. Find the expected value of the dress code violation. Well, remember, expected value was N times P, and we've already done this problem. So that's going to be N, which is 5, times 0.3, which is 1.5. So we expect there to be 1.5 violations. But that's actually not what this PowerPoint's about. That's review. We want to know what the standard deviation is. We know that the average is about 1.5 violations, but does it vary per year quite a bit or not much? So to do this, we're going to plug right into our standard deviation formula, and my N is going to be 5 days, and then we've got my P, which is the thing we're referencing, which is our dress code violations. So we're going to multiply by 0.3, and then I'm going to multiply by my complement, or the thing that I'm not referencing, the opposite, which would be that 0.7. And just do that on my calculator, and I get 1.02 violations. So although the average is 1.5 violations, the standard deviation means that the spread is about 1 violation per year. So we should expect majority of the data to be within 1 violation of 1.5. Remember, that's what standard deviation measures, the spread, how far from the average that your values are going to tend to be. All right, that's it. Make sure you're doing your assignments. Make sure you're studying for that test and doing the review packet. Hope you enjoyed the probability unit. Wish we could have done it in class. There's a lot of cool things we could do, but c'est la vie. All right, talk soon. Bye-bye now.